Hello everyone and welcome to our session. So today the speakers are me, Sebastiano Poggi, work in London at Navoda, and Eugenio.
Working in Berlin for Clue.
So today we're gonna walk you through the magical and mysterious world of text and typography. Now, has to be said, text and typography is not really a science, it's more a form of art, and as such there is rules, but they don't always fall into like really formal rules. Sometimes it's a bit more like creative, especially when you talk about Android in general. But why are we even talking about text? Well, there's one important reason. Text is important. Why is it important? Because what makes the difference between humans and other animals that we know of so far anyway is that we use a language as a mean of communication and to exchange information and share ideas. Now, this started really in the early days with cave paintings. That were the first time that someone realizes that, you know, people might learn stuff and they might exchange ideas, but at some point they tend to die. Because I don't know about you, but I think I'm quite bad at not dying.
Really bad.
Yeah. At some point, I guess. So they started writing down drawings showing how to hunt, how to do different things in their everyday life. Then at some point they realized that maybe someone was really bad at drawing. I don't know, probably. If I had lived in the prehistoric age, that would have probably been me. And then they realized, oh wait, maybe there's a more formal way of transmitting information and writing it down. So they created the first languages and alphabets. And an example of an early alphabet is the runes. Now, from there's been a long evolution. At some point, a guy called Gutenberg came out with a brilliant idea. What if instead of writing manually down everything, instead of having thousands of monks copying everything all the time, what if we had a way of doing it quicker? And he invented print. So print was a really big revolution because it allowed to share information and print books way quicker. So that gave the Western countries a big advantage over other countries that still hadn't developed that technology. And from there, of course, evolution hasn't stopped. And we arrived to what is now the modern typesetting, which is not just a digital typesetting. I mean, since the invention of newspapers and with the uprise of advertisement and other means of communication, there's been a lot of evolution and changes from what was in vogue at the time of Gutenberg. Now, this means that text has undergone millennia of evolution. And I guess all of you are developers, which means, you know, evolution, long term, there's a legacy. And as developers, when we hear legacy, we kind of shiver and get worried.
Yeah. This is what your project was complex. Like this is more complex.
Yeah. Because, it's a mess. It's basically, there's the way text has evolved organically over different countries, different ages. It means that there's basically no good way of standardizing it in a simple way. I guess that today, if we were to invent text today with the needs that we have, so transmitting information over wire and digitally, we would probably have a very different way of writing things down. I would say JSON everywhere.
Yeah, pretty much.
Today. Maybe in 10 years something else.
RX text.
RX text, yeah, that would be worrying though. Yes, but it's a mess. We know, but you have to say, it's a beautiful mess. It's not just a mess for the sake of itself. If you just look at how many different typefaces, just in a Western language, how many different ways of writing something you have, there's a huge variety, and it's really, really interesting to see the serifs, some serif slabs, and something else as well. someone invented Comic Sans, and not just that one, but it's the most commonly known example of bad-looking text and font. Okay, now, really quickly, I want to give you some more sense of scale. So when I say that text is complex and dealing with it is complex, I want to do a proportion. Like, let's just say we start with what you should try to have in your code. So a class that is probably shouldn't be more than 200-300 lines of code, because if it does, it's probably doing something wrong or too many things. So what you tend to do is to refactor things, to slim them down and have as smaller classes as possible. Now, that's a sensible maximum limit for the length of a class. But now, let's just look at some classes from the Android framework. So the first, just sticking to text, is typeface. Typeface is a class that mostly delegates to native. It doesn't really do much, but it's got a lot of hooks and methods and fields that it needs to keep in Java. And that's 400 lines of code, pretty much. Now, keeping the scale, let's just see the next one. So the next one is drawable. Drawable is something that is used, is an abstraction over something you can draw on screen. As the name says, it's quite easy. And drawable is about 1,400 lines of code, pretty much. Now, that is still not that big, because next up, if you just look, the next one I found was context. There might be other classes with different lines of codes in between, but just to give you an idea, context, is a big object. It's got a lot of responsibilities, and it can do a lot of things. Now, that's almost 4,000 lines of code, but there's more. If you look at something bigger, let's just say Vue. So Vue is basically the base class for everything UI in Android. It's a huge thing. Too big, probably. It's 22,000 lines of code. Now, that is not, there is no other class that we could find in AOSP that is bigger than that, in Java anyway. But the second biggest class in the framework, as you might have guessed by now, I'm trying to drive the point, that is text view. So handling text alone is the second biggest concern in class size, which is a really bad metric, but still, can give you an idea. Now, when I say that text view has got 10,000 lines of code, it's not exactly true, because if you focus on these two, yes, it's half of Vue, pretty much. But then you consider that there's a bunch of code from basically text view that has been extracted into a separate class that is called editor. And that editor class is basically only used in text view. I'm not going to go into what that does, but that is basically can be considered part of the text view size. So what you get is that actually the two together are almost as big as the view by itself, which is quite impressive, I think. And now, if you see edit text, you would think it's a big thing because it's a text view that you can change the contents of, right? Well, turns out edit text is just a text view with a couple of settings. So edit text doesn't really do anything for you, almost nothing. And I haven't forgotten the dot for edit text. It's actually there. It's really small in comparison. So just to give you an idea of this small fact. Now, when we talk about metrics and text, we need to know, when we talk about text, how do you lay out the text, how you measure it. And it is something that you cannot just say, okay, the text is from here to here. Just doesn't really work, right? Especially when you deal with a designer. The designer will be like, oh yeah, this font is 14 points, but then the senders are like 10, and the descenders tend to be 4. So just to give you a rough idea of where the baseline is, what did you just say? So let's just quickly see the main metrics. And we're just going to look at the main 4 ones plus 1, and these are just the vertical ones because those are the ones that have a meaning in general. Now, let's start with the baseline. The baseline we're developers. It's the origin of the vertical coordinate. That's quite easy. Now, that's the 0. But then you start having some content there. So you have, for example, a capital letter. The height of the capital letter above the baseline is called the ascent. It's called a caps height. All the capital letters tend to have the same caps height, usually in fonts, unless you are using a really weird font, in which case, good luck.
Happens all the time.
Yeah.
So.
Well, just don't do it. Well, there's not much you can do. Now, lowercase letters have what is called the x height, which is, well, the height of the lowercase x above the baseline. That's a standard measure of lowercase letters because, again, they tend to have the same, all of them tend to have the same x height, which doesn't mean that they don't go below the baseline sometimes because some details might, but they're all considered to be anchored on the baseline anyway. Now, next up is, we've said there is some stuff that goes below the baseline, right? And this is the metric that determines that measure is called descent. Next up, of course, we have stuff that goes above the normal lowercase letter. And it turns out that actually the lowercase letters that have an ascender, so a part that goes above the x height, usually are slightly taller than capital letters. Now, that is called ascent as a metric. For a second, we have seen a few of them, but what about when we have multiple lines? We've just seen stuff that is inside of a single line of text. So if we have multiple lines of text, what we see is that the space in between the lowest point of one line and the highest point of the other line, which in this case are the descent and the ascent respectively, might be different. That is called the leading. And it's another metric that we have to consider. Now, this is all nice and fine, but what about Android? How does it work on Android? Because those were design metrics, as in typography, pure typography metrics. Well, on Android, there's a class that is called font metrics, which is an inner class of Paint. And that exposes 4 metrics, which it's interesting. You have the ascent, you have the descent, you have the top, and you have the bottom. What? That's what are those? So basically, let's go back to the text we had before. So it happens to be that, first of all, we have to consider we are drawing on screen. So a first really important thing that has to be said is that the vertical coordinates are the opposite that you would expect. So, for example, well, the baseline is of course still 0, but the ascent, which is there, we have it, but it's going to be negative. And the descent, on the other hand, which we still have, is going to be positive. Now, that might be a bit surprising at first, but then you understand that the origin of points on a screen is at the top left corner, so it makes sense. But we have said there is top and bottom, and what really are they? So it turns out that not everybody only uses normal baseline Latin alphabet. There's a lot of languages that add accents and decorations and everything else. So the top is actually the highest that any glyph inside of a given typeface at that font size can go above the baseline. That means you are ensured that nothing will ever be painted outside of the top.
Well, can you be sure?
Oh, theoretically.
Yeah.
That's the contract, but then
sure, let's say,
Android.
Yeah.
So,
yeah.
Maybe.
Maybe.
Hopefully. And the same goes for the bottom. Like, for example, in Polish, you have the little tail, which is that funny character down there. And that would be going below the descender. And in that case, the bottom will include that kind of character as well. Now, don't be fooled by this. This is just to make you understand, but most likely when you use it in production, you will see that the top and the bottom are actually far away from those, from the top and the bottom of those decorations, because there's other glyphs in a font. Like there might be Japanese, there might be Korean, there might be some weird Indian dialect. Like there's a lot of possibilities for a top and bottom that don't really align.
I think it's also the choice of the typeface makers. If they want, they can include more space for beauty reasons.
Yeah, they could reserve more headroom. Now, what is the font size that you set when you set a font size on a typeface? The font size is basically the distance in between the top and the bottom. It's quite easy. And when you set that, you always have to consider that when you see like 14 points in I don't know, Photoshop or something else, those points are basically pixels at MDPI. And then this only works if the user hasn't set large text, because if there's an extra scaling on top of it. Basically, you know how SPs work. There is a scaling factor on top of the Ps, which in turn is a scaling factor on pixel. So it's a double scaling that you have to keep in mind when determining the pixel size. Okay, so that was the main thing about it. But how do we actually deal with the metrics?
Yeah, because we're missing like the X height and the caps height.
Yeah, we don't have those. You have to do it yourself. So what you do is you go there and you measure a string that is made of the one character you want to measure. For example, you want the X height. Well, you measure the lowercase x and see how tall it is. Sounds silly, but that's how you do it. Or the caps height, you just get a string with one cap, and that's your caps height.
And hope it's going to be the right one, because it could change, obviously. But
yeah, mostly is the one. And then don't judge. If you ever have to do that yourself, that's how you do it. There's not many ways around it.
Yeah. Okay, so we've seen a bit of history and typography, so the design perspective of it, but then we're interested in drawing on screens, because that's the new way of doing it, right? Okay, so you might be familiar with the difference between raster and vector. Raster is pixels and vector is shapes. You can have fonts that are both like made of pixels or made of shapes. We're not really interested in the raster ones. We're more interested in the vector ones that still have to be drawn on a screen which is made of pixels, right?
Let's just say raster fonts are the old fonts that you had on old system, because they didn't have the hardware capabilities to actually draw the vectors. Yeah,
because obviously for performance reasons, it's much easier to have pixels and just draw them on a screen. But then it doesn't scale if the screen changes or if the text size changes. So you might be familiar with TrueType and Opentype. This is like the Windows icons. We're very nostalgic. TrueType was the first format created for this thing and very popular, but then Opentype is actually the one that came after it, and it's much better. It has many features that you don't need to know all of them, but just know that there are plenty. For example, you have ligatures, which is when you have multiple characters that don't look very well together, or it might look better. They actually blend in some ways, and you have an entirely different glyphs. You have fractions. You have rules for substituting characters when they touch or not, or when there's like multiple characters together, they become a different glyph.
What do you mean exactly when you say glyph?
Yeah, a glyph is essentially a shape of a character inside a typeface, let's say. Yeah. For numbers, there's like 6 different ways to show numbers, and you can mix and match the different properties of it. And also, the typeface creators have a lot of freedom when designing that. They don't have to have proportional numbers or monospace numbers. They can choose whatever they want. And we're going to see, if you cannot choose, you might be stuck with the default, which might not be what you want. And yeah, that leads to hacks. We'll see that in a bit. So okay, That's the theory. Now the engineering problem is how do we go from a shape to a bunch of pixels? So drawing shapes, vector shape, is not a new science. Like, people have found ways to do it, but text has an added complexity in the sense that not only the shape that you're drawing, you want it to be as close as possible to the original, but you also want it to be readable. Because when you have very few pixels, it doesn't really matter if the shape is close to the original. It matters that you can actually distinguish it from the other characters, right? So a simple way to do it would be just, if enough of the pixel is covered by the path, then you make it black. Otherwise, you make it white, and that's the result. As you might imagine, this is very jagged, and when it's very small, it's not really readable. It's an effect called aliasing, and there's a technique called anti-aliasing, which tries to mitigate the effects of it. Now, this is probably better in a way, but it's still not as readable as we would like. So,
and it really depends who is doing the aliasing. The font engine makes a lot of difference.
Yeah, depends on the parties involved in the rendering process.
For example, there might be, if you're using a system that has been developed by Microsoft, you're gonna have, they're gonna prioritize legibility. Whereas if you use a system that is done by Apple, they say, oh, I like this typeface. I'm just gonna make it look pretty. I don't care if you cannot read it.
Yeah,
it's your problem.
There's also like a very original technique that I found. It's sort of a hack, but it's really effective. To show it to you, I need to open your mind first. So what if I told you that there is no pixel? What we perceive as a single entity is actually, on LCD screens at least, made of different parts. So the different colors, generally 3, could be more, are actually physical diodes on a screen, right? So what if you try to imagine that as your single pixel and have a grid of it, okay? And then turn on and off the single subpixels. The result is something like that, which is super weird to look at in a screenshot, because obviously like it looks just colored in a weird way, but your mind, your eyes actually get tricked when the light comes from the screen and the colors blend and you actually see them as sort of gray. I'm going to try and show you an example, although this is not the right screen to do it. But so if you turn the size down a little, you might see the difference between them. And if you want them one-on-one, this is actually how it looks like. It's quite interesting. But you can see that the subpixel one, well, sort of, is actually the closest one to the original and the more readable. So yeah. There's also a second technique. This is just for rendering, right? There's another technique called hinting, which is something that takes information from the typeface creators to know exactly where the pixels should align in the grid and maximize readability. It works together with the rendering, and it tries to maximize the readability.
It's basically the idea behind hinting is that if you have a straight line, then that should be a straight line. You shouldn't be aliased. So you can see it here. In the first case, like the ascenders of the B are blurred, whereas in the second line, using hinting, the system knows that when rendering that glyph, that should be exactly on a pixel, so it doesn't look blurry.
Yes. So what on Android then? Android, as you might know, uses something called Skia. It's an open source project for 2D rendering used in like Android, Chrome, what else? Other
Sublime
things.
Text?
Sublime Text 3, yes. It can draw essentially anything 2D related, except text. It doesn't know how to draw text. And it uses FreeType, which is another open source project used by many more. Actually, even iOS, Linux, and others use FreeType, because it's like the biggest open source project for that kind. FreeType itself had, for a very long time, a hinting engine, which was good enough, I would say. And you might have noticed since Android 4.3 that they actually work with Adobe to release their hinting engine, which is so much better. And now everybody using FreeType can benefit from their amazing system, which is
Thanks,
great.
Google.
Yes, thanks, Google. Absolutely. OK, so Android, there's something else you should know. It's called spans. You might have used them or not. I'm going to introduce them quickly. Essentially, when you have a string, okay, a string is made of characters. And spans are not extra characters. They're literally metadata attached to a range of characters. And spans could be anything. The system doesn't enforce any interface or base class. They can really be object.
Yeah, which is a really nasty API.
Yeah, the APIs are not great. Like, you need to iterate through an array. Yeah, anyway, that's the way it is. So spans, why are they useful? You can use them for your purposes. So you can attach any object and retrieve them later. But they're even more useful when the system uses them. And in fact, the framework spans are even more interesting than the custom ones. So I'm going to show you how many are there. There's two packages mostly that you should look into, Android text, Android text style. And inside of those, you have a lot of them. So you don't need to know all of them. But if you ever need to do something crazy, like a very specific customization of text, you might want to check them out. They're like not very documented as usual. But if you look at the source code and just experiment, you should be fine.
Yeah. It's also quite interesting to see, if you look quickly at the stuff that is in the text style package, there's like a text-to-speech span, there's a spell check span, suggestion span. There's like a lot of stuff that you wouldn't expect is actually implemented using spans, which is a quite interesting.
Yeah, as a matter of fact, even cursors are spans, and selection are spans. So yeah, what's important to understand is that it's not just for changing the rendering side. It can also change the layout. It can change the behavior of stuff. It's very interesting. Something I should say, so all of them, they actually implement parcelable span, which means every time there's a configuration change or the app goes into the background and needs to be recreated from scratch, they will be saved. So your text, if you attach spans of this kind to it, they will be carried over when recreated. If you try with your custom spans to implement parcelable span, it's going to crash your application. So whenever you need to carry your own information, you either do it by hand, so you create your custom view or activity and by hand recreate everything, or you could use the annotation span, which allows you to add like a key value of your choosing and carry information that way. It's pretty weird.
But then you still have to read it when you come back to it.
Yeah,
and recreate your own spans.
It's only a vector of information, but you still need to recreate the actual spans. But yeah. Anyway, that's the way it is, and we cannot change it. OK, so how do we deal with spans? You might be familiar with string, which is a Java class, and the big brother, string builder. What's the difference between them? Well, string is immutable, string builder is mutable, so you can actually change the contents of the string. And so this is pure Java. OK, there's nothing more to it. Android adds another layer. It starts with the span interface, which allows you to get let's say, read-only mode spans. Again, it's implemented by the base class span string, which is like an immutable string with immutable spans. Well, read-only, not immutable, but you get the idea. Then spannable, extend spanned is implemented by spannable string. Again, the string is immutable, the span is mutable. So this time you can actually change the spans attached to it. You might guess where this is going. Editable. Implemented by spannable string builder, so you can change both the spans attached to it and even the string itself. Okay. Interesting that for text view you generally have a spanned, and for edit text you have an editable.
Yeah, that's the difference I was telling you about. Those 150 lines of code are actually just saying don't use a spannable, use an editable.
Yeah, it's like configuring the base class. Yeah. Okay, good. So how do you draw text on Android? You use a text view or edit text. That's how you do it generally. There might be some times where you want to go further, like you want to create a custom component, or you have very specific needs, like you need to know exactly how big the text is in order to,
draw it on a bitmap.
Draw it on a bitmap, or or any kinds of UI issues you might have. So how do you deal drawing and measuring text without text view? You do exactly what text view does. You use a layout, which is not the normal layout you might imagine. A text layout is essentially, well, you can imagine it as a view in the sense that it will handle its own measuring and drawing, but it doesn't extend view at all. For performance reason, this is just a convenience class that allows you to measure and lay out and draw text, which is very complex. Like, never try to write this yourself, because this is crazy. It's a huge class. It has 3 implementations. So the first one is boring layout, which is the simplest case you can imagine. Single line, right to left, and that's pretty much it. Again, keep in mind, this uses spans.
You mean left to right?
Left to right, yes. This uses spans to do all the measuring, to do the different rendering if you want. So this is supported. Well, we'll see later, if you go deeper and actually do the rendering, spans are not supported. Spans are a concept created by Android for this. Second one is static layout. As you can imagine, it's like every other case where the text is immutable. So you can have multiple lines, you can do pretty much whatever you want. It's obviously more efficient than the next one, which is dynamic layout. This is a layout where you can actually change the text. It caches some results, and it tries to be as efficient as possible, but yeah, it will not be.
It's basically static layout is spannable, just as editable is for the dynamic layout.
Yeah, if you try to change the spans on a static layout, can you do that? I don't know. Well, experiment. You'll figure it out, don't worry.
Good luck.
Yeah, but then how do they, in turn, do all the measuring and rendering? So we need to go deeper to understand that. How do we render text on Android? So, well, there's a method on Canvas. Canvas is a Skia class, essentially. It's a wrapper around Skia. Draw text is very simple. You give it coordinates, X and Y, you give it the text, and you give it a paint, and it will paint your text, okay? Again, keep in mind that it will paint the entire text on one line with like one color, and that's it. If you want to have different words with different things, and you want to do it by hand, you would have to literally measure every single step and render every single character or word in a different way, which is crazy, and it's the reason why we use layout. The other one is draw plus text, which is deprecated. I don't know why it's in the slide, but yeah.
Because it's deprecated.
Yeah,
it's still there.
It's still there, anyway.
Yeah. Don't use it.
Don't use it. It's technically, you can give it an array of position for every single character if you want to somehow do stuff with it. And then, much more interesting, draw text on path. As you can imagine, you can draw text on any path you like. It's quite powerful, and yeah, you can have fun with shapes. There's another method which is not performant, but if you ever need to do special effects, you might use it. You can ask a paint to give you the single path of every single character in a string, and then draw them. If you've ever seen any of those fancy applications where they draw the graphics like with a line that it's drawing things little by little, you can do the same with text this way, for example. Why not? As usual, there's a problem, because it's never so easy. Hardware acceleration is an afterthought on Skia, in the sense that originally it wasn't there at all. And then they realized that the CPUs couldn't keep up with the screen sizes. And so they say, yeah, let's add hardware acceleration, except they didn't add all of it, just a portion of it. So for text, what does it mean for you? It means draw text on path is not available before 16, fortunately. So if you need to do it, you will have to draw it on a bitmap or disable hardware acceleration. And also, there's a problem with scaling. So normally, when you draw something, it will be drawn one-on-one on a GPU texture and then rendered. So that means that if you scale that, it's going to be super pixelated, and you're going to see lots of artifacts. That's depending on the call you make. For example, on draw text, before 18, that's what happened. So if you ever wanted to scale your text before that, you would have to pre-scale it on a bitmap or something, or again, disable hardware acceleration. Draw text on path is not supported at all, so again, same tricks. And draw path, in case you go through that route, is also not supported at all. Yep, so the other little piece is paint, which is the vector that carries information to the native code, to Skia, to actually do the real drawing. There's a subclass of it called text paint that has some extra methods, especially for text. What do we have? Well, background color, baseline shift link color, drawable state density. Well, it's pretty self-explanatory. What's interesting is that it has some hidden properties like underline color and underline thickness, which are very useful. And the only way you have to access them is through reflection. But as usual, word of warning, don't try to do it if it's not really necessary. And even when it's necessary, always fall back to the case where it's not working, because it might happen. I guess the alternative is to draw it yourself by hand.
Don't do it.
Don't do it. What else? Yeah, there's also a few flags that you can use while painting. Pretty self-explanatory, the one on the left, but the one on the right are quite interesting. So whenever you are drawing text, it's actually doing a lot for you. It's caching all the render text in a sort of atlas, and then using that instead of redrawing every time, right? But what if you want to animate your text? For example, you want to scale it from bigger to smaller. That means your cache, your atlas, is going to be completely useless, and even it will add overhead to it, right? Because every single step will be drawn to this atlas, and it's going to blow up.
And it's going to be uploaded to the GPU every time, because let's remember, this is done on the CPU and then uploaded as a texture, so it takes a lot of time.
And also, with the hinting and all the rendering tricks, every time you try to change the text size, it's going to be slightly different than before. So it's not just going to be like a path scaled up or down. It's going to be a different sort of shape every single time, and the effect is absolutely terrible. So if you use the linear text flag, this actually disables all of that. And when animating, it's going to be super smooth, and the effect is going to be perfect.
And then take it out when you're done.
Yes, absolutely. Subpixel text, so subpixel rendering is not available on Android at all. You don't generally need it because you have enough pixels anyway. But if you want to still lay out your text as if it was subpixel rendered, you can. It helps at times.
Might slightly improve the
measuring,
and it's on by default, I think, anyway.
It depends on how you create your paint.
Yeah.
It's off by default, but you can, you should enable it if you have small text or something like that. And then hinting, as we saw before, you can turn it on and off. It's on by default, and that's it. Interesting again, hidden flag, don't use it, but this is the real subpixel rendering. It's LCD render text flag. If you just want to see how it looks, you can try, but never use it in production. I really advise against it. If you want to know more about especially the GPU side, like the hardware acceleration side, Romain Guy has made an amazing article about his own experience writing that part of the framework. It just gives you a sense of the complexity, and it's amazing. And this is just a specific portion of the rendering pipeline. So imagine doing all of it. It's quite crazy. You can find a link here. We'll publish the slides later so you can grab it. Again, hardware acceleration goes and, I don't know, breaks all our dreams again, every time. So there's no set anti-alias before
it does break them, but it makes them buttery smooth.
Sure, yeah, it does when it works. Anti-alias is something you would assume to be working every single time, right? But it's actually not before 18. So you would see this very pixelated text if you try to use hardware acceleration for text. Set linear text doesn't work at all. Subpixel test doesn't work at all. So when you're using hardware acceleration, be careful, because those will not be working.
If you do animate text, disable hardware acceleration and use linear text, and then swap it back.
Surprisingly, well, if you're scaling the text.
Yeah, if you're scaling it.
If you're moving it, then it's fine. Don't worry. Yeah. OK, some cool stuff that happened with Lollipop, actually. We have some new methods and things that were not possible before. For example, set letter spacing allows you to add a specific spacing between each character, which is something you would assume is super basic, but it just wasn't there. And every time you had to stretch, for design reason, a string, you just had to use crazy hacks again, like introducing a character and then using a span on that character to stretch it. It's like, now it's native, you can use it, and it works. Then we have set elegant text height, which nobody really knows what it does. Like, the definition is selects font variants that have not been compacted to fit Latin-based vertical metrics, and also increases top and bottom bounds to provide more space. I don't know. yeah, something.
Supposed to be making it look slightly better.
Yeah, I guess, but only for certain typefaces.
Yeah.
I tried and it doesn't do anything for this. Anyway, yeah. And then the real deal, the actual revolution that happened in Lollipop is set font features. So we've seen before the Opentype features, right, that are actually already available on CSS. When you use CSS on the web, you can change all of them, turn them on, off, and stuff. It was absolutely impossible on Android before. So if you wanted to change any default, you couldn't. And now you finally can with this. And it uses the same syntax as CSS, which is a nice added benefit. So yeah, that's really cool. And you can do so much with that. Unfortunately, Lollipop onwards. So yeah. OK, so this is rendering, right? When you want to render text by hand, this is what you do. But you cannot do it unless you know where to place it. Because with all the baseline stuff, if you try to just draw it at coordinates 0, 0, you will probably not see anything because it will be over the screen, essentially. So you need to measure. How do we measure text for real, like at the very low level? So first of all, let's have one string. You want to measure the string. You have two methods mainly. Paint measure text gives you the actual length of the text, including all the paddings of the single characters. There's a lot of confusion, especially on Stack Overflow. We should post a reply to it, because like this age-old discussion about the difference between this and getTextBounds. And people never figure out the difference between, because they yield different results, as you might imagine. Well, one is a float and the other is a rectangle, yes. But the widths are different. That's because getTextBounds actually gives you the exact bounds of the single shape, of the single glyphs of every character, while measure string, measure text gives you the real string of the real width of the string, right?
That you need to consider when laying out stuff.
Yeah, exactly. Like when laying out stuff, the first one is the one you want to use, not this one. This is for very, very special effects. Like I really want to cram as much space as possible or something. So,
or to measure glyphs if you need.
Yeah,
exactly. That's what you would use.
Yes. OK, but then what happens when you actually? So imagine you want to write a text view from scratch for a science experiment. How do you get the real height? And that's, as we said before, when the font metrics top and bottom come into play. So if you use those as your height and measure text as your width, you will have the real bounding box, which is exactly what text view or the layouts do when laying out and rendering text, right? Interesting enough, text view also allows you to not use top and bottom, but as an indecent. There's a property called include font padding. It's on by default, but you can turn it off in case you want to, cram the text even more.
If it's off, it's going to use the accent and decent.
Accent and decent, yes. And yeah.
So basically, if you're sure that you're never going to use anything that goes above the top or below the bottom, then just enable it.
Yeah, but even there, like
there's very little cases where you should do it.
Always, never assume anything, because fonts are crazy and they're generally not even done to be drawn on mobile. They're made to be drawn on print and stuff like that. So always experiment and try, because it's gonna be weird. And also, if you do getTextBounds, it might be off by a few pixels. Keep that in mind. It could be 1 or 2, but it's never gonna be exactly perfect. So yeah. Always
you might see your text being slightly inside or slightly outside of the bounds. It's kind of a rough estimate thing.
Oh, and one other thing. The bounds are actually rectangle, but the interesting information inside the rectangle is not just the width and height, it's actually the position of the rectangle. And that's because, as you see, it might be shifted because of the character spacing. And yeah, that's what you have. Yeah. OK. There you go.
So now, the world is not just us, and what you've seen, you might think that was complicated, but that was just bread and butter things.
The basics.
It's like the basics. If you live in a Western country and you only use one alphabet that only goes in one direction, it's easy-ish, easy. If you want to step up your game, what you would do is you would start considering that there's other ways of writing text. There is just saying that the main ones are, well, we use left to right, but there are cultures that use right to left, which we're not really used to, probably. But so left to right is exactly what you would expect from text. That's what you would write if you were to write to something. But then someone that comes from the Middle East might actually write in Arabic, and they would start from the right. And that's how the Arabic and other languages work. Now, that is, in and by itself, quite a funny thing, because you need to start thinking, oh, wait, is my text going to be in one direction or in the other? Well, you don't do it because the layout does it for you. That's why you should never do laying out the text yourself, because that's just stupid.
And painful.
And really painful, yes. But there's one more case that is what will definitely drive you nuts, which is embedded runs. So if you take a run of text, so any amount of text that goes in one direction, not the band, and you have inside of that run of text something that might be in a different language that is maybe in the other direction. So for example, you might have some Arabic text which contains the title of a book in English. I've just taken that one off of the BBC Arabic news website, which is actually quite interesting. I cannot read it, but it looks nice.
You should say about the cursor.
Yeah, don't worry.
Okay.
Don't worry. One more thing I want to say before the cursor is, you might notice that that text is quite low quality. That is because Keynote doesn't know how to handle that text. It just screws up completely and shows text all over the place. What is supposed to be happening here, and the way text is supposed to be dealt with, is that you start from the right until you get to the question mark, which is an Arabic question mark. After that, the text is logically continuing from the H, and then you would still you would resume going from left to right until you reach the end of the Y. After you press right again at the Y, you will go and jump to the quotation marks. You press right again, and you go left. So that's a funny thing. I don't know if you've ever tried, but if you have like Google Drive and you start copy-pasting embedded runs, you will understand how crazy it is, because you press right and it goes left and then it goes right again. It's really messy. Again, don't do it yourself. Don't hurt yourselves. There's really literally no reason to do it. And there's something else. This is not all, because there are languages, and again, Arabic is a good example, that require shaping. What is shaping? Shaping is basically if you take any single character inside of the alphabet and use it by itself, just putting one after the other to form a word, like this. I don't know what that means, but still, that is a word. But if you take it as it is, like that, and you show it to someone that speaks Arabic, they look at it and like, what is that? That doesn't really make sense. So what you do, and it's not just Arabic, there's a bunch of other languages that need this as well. What you do is you do shaping, which means you change the shape of the glyphs when they are close to each other. And that's basically a really extreme variation of ligatures, if you will. Mm-hmm. You change the shape of the glyphs, because then when the word is formed, then putting all the characters together, then and only then it makes sense. Now, again, this is really complicated. Luckily enough, the system does it for you. If you're using Android 4.2 or later, because before then, support was patchy at best. And before 4.0, I think, there was basically very, very little support for it. So 4.2 is a safe bet. Anything before that, no. Don't do it.
It even helps with when you do layouts, like XML layouts, the real ones. You have automatic support for mirroring of all the things, which is great.
Yeah, including bitmaps.
Yes.
So, what about before? So if you had something that you had to support, I don't know, Android 2.3, may God help you, then what do? Well, you do Axe. You just hack your way through until you can make it somehow. And it's crazy. It's crazy, it's going to be slow, it's going to be painful, it's not going to be perfect, it can kind of match it. So why am I saying this? Because actually, I had to do it. I was working on this smartwatch, which is called iWatch. It's now, company's closed, but the product was launched in 2011, and it was a smartwatch running Android. Now, you do the math. In 2011, we had Android 2.3. not 4.2. Now, the iWatch actually didn't even run Gingerbread. It ran Android 1.6 because of various reasons, including performance and hardware that was available at the time. So we couldn't upgrade it. Even though 4.2 was available at some point, we couldn't upgrade it because it wouldn't run on it. So how did we do it? We had to support Arabic because we had customers in the Arabic Peninsula that needed support for it and proper support for it. Now, how did we do it? Well, you can guess. Hacks, of course, all over the place. So what we had to do was to basically, every time some run of text was to be displayed, when it was assigned to a text view, for example, we would have to cycle through it with a for loop and just detect when there was a glyph that was meant to be in an alphabet that has a different direction, and basically inject Unicode control characters. That is the only way we could find to make it work on Android 1.6. And we were lucky that there was some basic support for bidirectional text because it was in the Unicode specifications. It just was not enabled. And so you had to inject those control characters in there to make the system think, oh wait, I actually need to show this the other way around, or I need to show this embedded run in a way that makes sense. So yeah, it's been quite funny, not to say painful.
Was this the reason why the company closed?
Yeah,
okay.
No. It wasn't, but it could have been.
Could have been,
Yeah. Now, this is the main takeaway of this whole section that I've done on left to right and right to left. Do not do anything before API 17. Ever. If you're asked, oh, should we support Arabic? We need that as a business. And you say, yeah, that's fine. Let's just bump the minimum SDK version to 17. Business is gonna say, no, but you know, the project manager's nephew has got a really shitty Samsung phone from 2012 that runs Android 4.0. Well, you say either that or you give me 4 years to do it.
It's less expensive to buy a new phone.
Yeah, it's less expensive to ship new phones to customers than it is to actually code all that stuff yourself. So yeah, that's the main takeaway, and also a good leverage point for you if you want to bump your SDK version and get some of the niceties that you will get in Jelly Bean.
You can link our presentation as a source if you want. Yeah,
it's his fault.
Yeah.
Okay, so this is it. The slides are going to be uploaded at the link at the top as soon as we have the time to. So I guess by the end of the day. And
yeah, there's a bug currently on Speaker's Deck, which makes the slide horrible. Like all the colors are wrong, but you can still read them. So yeah. Yeah, and we will link the keynote presentation as well. Yes. So if you want to see how we did it or anything, you can. And our companies are hiring, by the way. We should say that. Yeah. Both of us. So join us. Come play with us. Yeah. Berlin, London, Berlin, Barcelona, and Liverpool. Yes. If you have any questions, we have 5 minutes-ish. Yeah. So if there's any question, and we're not available to come and fix your text issues for you. No. We've dealt enough with it. You can grab us later, though, if you want to ask us in person. Yes. And you can also ping us on Twitter if you want. So. No questions? No? Yes. That good. No. So the question is there any specific requirements for Android Wear? The answer is no, because Android Wear was born on Android 4.4, and it's a normal Android distribution, so you get all the stuff for free. And Android Wear, you can actually be ensured that it's going to be updated to the latest version. Like all the devices will receive an OTA because it's Google doing that. Currently, I think it's on 5.1, and they should release an update to Marshmallow 6.0 at some point. Yeah, but all of it applies the same. It is Android 100%. So you can use everything you've seen in the presentation, every single thing, on Android Wear without any problem. Anybody else? Any other question? No? Cool. Okay. Thank you very much. Thank you. Don't forget to rate the session if you liked it. Yeah. And we have stickers if you want. Oh yeah, we also have stickers. Yes. Come over.